Hello everyone, this is Divya, working as assistant professor in Triple Department at St. Peter's Engineering College. Today I want to explain about the physics of wind power, part 3, under the course Wind Solar Hybrid Energy Systems. So, today I want to discuss mainly on the types of wind turbines and sizes of the wind turbines, what are the advantages and what are the disadvantages. So, coming to the types of the wind turbines, the first one is the horizontal axis type. So, a horizontal axis machine has its blades rotating on an parallel axis that means parallel to the ground. So, that is a single blade horizontal wind turbine. There exists and two blade horizontal wind turbine and three blade horizontal wind turbine. So, the blade weight and less cost, that is the blade is very lower weight and having very less cost in the single blade horizontal wind turbine, and that is more vibration and unconventional look in the single blade horizontal wind turbine. Coming to the two blade horizontal wind turbine, it is similar to a single blade horizontal wind turbine only, and it has stability problem. And coming to the balanced, that means a three blade horizontal wind turbine, there is a balance of gyroscopic forces increasing the gearbox cost. Even though the gearbox cost increases, there is an efficient result. So always we are going with three blade horizontal wind turbines only. So, large three-blade horizontal axis wind turbines with the blades upwind of the tower produce the overwhelming majority of the wind power in the world today. So, these turbines have the main rotor shaft and electrical generator at the top of the tower and must be pointed into the wind. So the small turbines are pointed by a simple wind vane, while large turbines generally use a wind sensor coupled with a yaw system. So most have a gearbox which turns the slow rotation of the blades into a quicker rotation that is more suitable to drive an electrical generator. So some turbines use a different type of generator suited to slower rotational speed input. So these don't need a gearbox and are called direct drive, meaning they couple the rotor directly to the generator with no gearbox in between. So while permanent magnet direct drive generators can be more costly due to the rare earth materials required, so these gearless turbines are sometimes preferred over gearbox generators because they eliminate the gear speed increaser and which is susceptible to significant accumulated fatigue, torque loading, related reliability issues. So and maintenance costs also less. So there is also a pseudo direct drive mechanism which has some advantages over the permanent magnet drive mechanism. And next, going to the next type, that is vertical axis type. So the vertical axis wind turbines have the main rotor shaft arrangement vertically. That means in perpendicular with the land. So there are again two types, that is Darius wind turbine and Savion's wind turbine. Coming to the Darius wind turbine, they are having good efficiency, produce large torque and silic structure on the tower, require some external power source to the start turning. And coming to the Savion's wind turbine, drag type turbine it exists and used in case of high reliability in many things such as ventilation and anemometers, and it is a self-starting but it is less efficient when compared to the Darius wind turbine. So coming to the vertical axis wind turbines have the main rotor shaft arranged vertically. So one advantage of this arrangement is that the turbine does not need to be pointed into the wind to be effectively, which is an advantage on a side. where the wind directly is highly variable. So it is also an advantage when the turbine is integrated into a building because it is inherently less steerable. So also the generator and gearbox can be placed near the ground itself. So using a direct drive from the rotor assembly to the ground-based gearbox, improving accessibility for maintenance, and however, these designs produce much less energy averaged over time. So, which is a major drawback of this one. So, the key disadvantages include the relatively low rotational speed, which consequential high torque and hence high cost, which is a drivetrain. So, the inherently lower power coefficient 360 degrees rotation of the aerofoil with the wind flow during each cycle and hence the highly dynamic loading on the blade. So the pulsating torque generated by some rotor design on the drivetrain and the difficulty of modeling the wind flow accurately and hence the challenges of the analyzing and designing the rotor prior to the fabrication a prototype. So when a turbine is mounted on a rooftop, that means top of the building, generally redirects with over the roof, and this can double the wind speed at the turbine. So if the height of the rooftop mounted turbine tower is approximately 50% of the building height, it is near the optimum for maximum wind energy and minimum wind turbulence. So while wind speeds within the built environment are generally much lower than at exposed rural sites, so noise may be an concern and an existing structure may not adequately resist the additional stresses. So the subtypes can deliver better achievement in this. And next coming to the size of the wind turbine, in the wind turbine delivers energy less than 10 kilowatt. It is said to be small. It can be used at homes, farms, and remote applications. For example, water pumping and telecom sites. The wind turbines are said to be intermediate if they can deliver energy 10 to 250 kilowatts. These can be used at village power generation and hybrid systems and distributed power systems. And finally, the last one, that is large wind turbines. These can be termed as when the turbine is delivering 250 kilowatts to 2 plus megawatts, then those are named as large wind turbines. So these are called as central station wind farms. These are used at central station wind farms, and these are used as distribution power wind farms also. So you can see here, these are the current data. So 0.15 megawatt, 0.75 megawatt, 1.5 megawatt, 2.5 megawatt, 3.5 megawatt, and 5 megawatt are the current running state wind turbines. So the performance of the wind turbines depends on the five major factors. The first one is the wind power, and the second one is abstractions, and third one is altitude, fourth one is air, that means temperature, and the next one is blades, that means aerodynamics. How much wind power you are delivering, that one is the first one. Second one is the abstractions. When you are using any wind turbine, when you are generating the electrical energy by using any wind turbine, what are the obstructions you can face there, that will be a major performance factor. And the next one is altitude, the wind coming altitude, that also a major performance factor to generate the electrical energy by using wind turbine. And the next one is air, that means that the air should be not much more and not very less to generate the wind energy. And next one is blades. If you consider only two blades, that is not efficient. If you consider more than three blades, that is also not efficient in some cases. So you have to be fixed only three blades according to that place. So that is also a performance factor. So this is about types of wind turbines and performance factors. And next we will go with the advantages and disadvantages. So the advantages of wind turbines are these are very good for environment as it uses renewable sources of energy as wind, and wind is very freely available in nature and can be set up in remote areas where electricity through transmission wire cannot be reached. And this is a clean source of energy as it does not produce any greenhouse gases or any other pollutant, so it is not harmful to any human being or any culture. So once setup is completed, the cost of the generation electricity become less. Only the investment cost is high, but the generation cost is not high for this wind turbine. So can be combined with solar electricity to give a reliable supply of electricity. And comparison cost of different sources are by using power plant type, which type of here this table shows the comparison of different sources. This is the natural gas. For natural gas, the cost per kilowatt hour in dollars is 0.07 to 0.13. For hydro, that is 0.82, that is 0.08, and for coal it is 0.08 to 0.14, and for wind it is 0.08 to 0.15, and for nuclear it is 0.10, and biomass it is 0.10, and for solar PV it is 0.13. So these wind, um, hydro, and biomass, solar PV, these are the renewable sources, right? And for the emission of different power sources for electric generating electricity, here the coal field having maximum emission, and natural gas having next to maximum emission, solar PV very light, and wind is also very light. So we can we cannot harm the atmosphere, so we can go with these wind turbines to generate electrical energy. And coming to the disadvantages, the site specific that is suited to the particular region. If we are selecting any particular site, we have to decide if that site is suitable for the generation of electrical energy by using wind turbine. And that creates a lot of noise disturbances because the wind turbine when it is operating it creates lot of noise disturbance. So we have to keep in mind that the surrounding is a non local locating place, so we have to decide that one. And the next one is prediction of wind is difficult, that is wind speed varies. This is the most important consideration that also I said in the performance factor, the wind prediction. So the wind in which direction most of the wind comes to that particular place, that identification is very important. And threat to wildlife as it kills birds. So there should not be any birds in that way. We have to take the precaution, cause visual impact and high initial cost, large requirements of land for wind farms, and turbines interference with the reception of televisions and communication signals. So the signals may be a breakdown due to these turbines. So we have to take care when we are installing these turbines. So these are the disadvantages of using wind turbines.